Okay, everyone. Hello, and welcome to our webinar on using CloudShark and Airtool together to do wireless packet analysis. My name is Jason Walls, and I am from CloudShark. And with me is Adrian Granados, the creator of Airtool. Say hi, Adrian.
Hello, everybody.
And he is actually going to give the majority of the presentation today and show you how to install Airtool and how to upload captures to CloudShark with it, and then show you some of the basics of looking at Wi-Fi packet captures. We might as well get started, and what I'm going to show you first is the one thing that you will need to use Airtool and any any tool that integrates with CloudShark using the API uses an API token. So when you sign up for CloudShark, you will see an API token. You will see in your preferences menu this link to your API token, and if you click on this, it'll display it right here. You can also make new API tokens in addition to this one. Like for here, on the last webinar that we were doing with Meraki, I actually added one that has a tag setup. But your base API upload token is this one right here. So you're going to take that and copy it. And then when you go into Airtool, as Adrian will show you, you'll see a place to put that in. So what I'm going to do is actually hand things over to Adrian.
Well, just a little bit about me. Adrian Granados. I've been working in wireless networks for the past 10 years, but mostly on the ad hoc networks, wireless network simulation, some protocol design, and other exciting stuff. That's my day job. By night, I am a software developer. I'm the maker of Airtool. I also have other Wi-Fi tools for Mac and the iPhone. I'm also 40 megahertz intolerant. That's a joke that you probably will get later in the presentation. So about this webinar, I'm gonna talk. I'm gonna start with some considerations to when we are doing frame captures for wireless networks in Mac. Well, in general, but we're going to be using Mac OS. Then I'm going to show you some tools you can use for doing frame captures on Mac, and then I'm going to explain what's Airtool, and then the Airtool CloudShark integration, how to install it, configure it, and then some examples of wireless analysis using Airtool and CloudShark, and we're going to end up with questions if you have any. So when we are going to do captures for wireless networks, promiscuous mode, as is usually required for wired networks, is not good enough. Because by default, the wireless NICs do not pass any management and control frames up to the network stack. So in wireless networks, we have three types of frames. We have management frames, control frames, and data frames. Management and control frames are used to it's for the control end of the network, and to, for example, joint associate to the network, disassociate, all that stuff. Data frames are, of course, the application data packets. The other thing to be aware of is that wireless networks are half duplex. This means that the NICs cannot receive packets while transmitting, and vice versa. So you can only receive or you can only transmit. So if we're gonna capture frames, we need to put the interface in something called monitor mode, which is like a passive mode for wireless NICs, where they can only now listen for frames, they cannot transmit. So in monitor mode, the NICs become passive devices that listen to all frames on the channel they are currently operating. Although this is not entirely true, we will see later why. In Linux, some drivers support monitor mode, others don't. Same for Windows. In Mac, the built-in Wi-Fi card supports monitor mode out of the box, which is very nice. So there are many tools you can use to do frame captures on OS X. We can start with the wireless diagnostics. This is a tool that comes with this operating system. It's very simple. When you choose the channel, you choose the width, and you start capturing, it creates a file on your desktop, and that's it. Then Wireshark, I'm pretty sure everybody is very familiar with the tool. Then there are some command line utilities like AirportD, TCP-DOM, T-Shark. Some tools like TCP-DOM require the interface to be disassociated, and this is because of this. So Wireshark, for example, in wireless diagnostics will disassociate the network interface for you, but tools like TCP-DOM, you have to do it manually. And to do that, you have to use this little command line tool called Airport, which you can find under System Library, blah, blah, blah. You can find it. You can see the path there. So what is Airtool? The idea with Airtool is to make captures frame capturing easier. It's a tool that sits on your system menu bar. It provides basic functions to check Wi-Fi state, configuration, and you can perform frame captures on single and multiple channels. This is a key difference with other tools. In the other tools, you can only capture on one single channel. With Airtool, you can capture on multiple channels, although it's not simultaneously because that's not possible. What Airtool does is that it switches to a channel, waits, and listens for an amount of time, then it hops to another channel, then the next one, and it goes. So it's not, you are gonna miss frames, but for some cases that's useful. So other thing is that their tool integrates very nicely with CloudShark. It integrates in two ways. The captures that you do with Airtool can be automatically uploaded to CloudShark, or you can manually upload any captures that you do, for example, with wireless diagnostics or even Wireshark. So to install Airtool, you go to a website, download it, double click the installer, and then you launch it. I'm going to show that right now. So you go to www.adriangranados.com, apps, Airtool. Here, you get to this page, and then on the bottom you see download Airtool. Airtool is free, by the way. So you just click on it. Then launch the installer. You go through the wizard, then you agree to install it. Install. It's gonna ask you for your admin password, just because it needs to do some configuration so you can capture frames with the tool. It's basically setting up permissions on the capture devices, and that's it. Now you go to Launchpad, launch Airtool, and now it shows up here. So here you can see the status of the network. It says it's associated, the current channel width, 20 megahertz. You can disconnect from the network. You can turn off the card. And then we have these options for capturing. You can capture, this option capture will capture on the current channel. So if I click on here, it's gonna capture on channel 1, which is the one that's set to right now. Or you can capture on any other channel. If you pick one channel that is not currently set up, then Airtool will disconnect from the network, switch to that channel, and start capturing. And then you have the options to capture on multiple channels. You capture all the supported channels. This is for 2.4 and 5 gigahertz, or you can choose only one band, or you can do a custom where you choose which channels you want to capture on. Now, let's go back here. So configuring CloudShark, as Jason said before, you need your API token with upload capture files permission and the appliance URL, which for many of you will be www.cloudshark.org. And the way you do that, I'm gonna go to my, this is my appliance. So we will hit preferences, API tokens. I copy the token and I go to Airtool preferences. Oh, sorry, it was there, but the idea is that you put it there. Then my appliance URL is surf.cloudshark.org. Then you go to General. And when it says capture files location, you're going to choose CloudShark. That means that when you do the capture and when it's done, then it will upload the file automatically to CloudShark. So for example, I do right now, click capture. It's going to start capturing. Then when I now it shows up in here. I had the notifications disabled, so you didn't see notifications. So let me try it again. See, you get a notification here where when the capture is successfully uploaded. You can click on it and it points you directly to the capture in CloudShark. Here is the one that we just did. You can also see them here. If you click again on it, it will open it in your browser. One of the other things you might want to do is to set a file size limit. I don't remember if that's the case right now, but when I did the integration, I remember there was like a limit for trial accounts and stuff like that in CloudShark. So I come up with this option to limit the size of the capture, and it's good anyway, because sometimes there's a lot of traffic going on, and you might want to get only a few kilobytes instead of.
So for people who are either have an active free trial on cloudshark.org, or if you have a personal or business account, you can use that field to set it to the upload limits that you have there, and then you know that it'll never be too big of a file.
All right, yeah, because if it's too big, then our Airtool is gonna come up with an error, and you will not be able to upload it to CloudShark. Use that by going to Preferences, General, and then clicking on Limit Capture. I'll show you. Preferences, General, and clicking here and setting the size in kilobytes. So this is something we just did. We did a capture. It shows up in your notifications. You can click on them to open the capture in your browser. You can do also manual uploads. And a manual upload will allow you also to set tags and comments for your capture. So we just do upload to CloudShark. You have to pick, let's say this one. Then you could click on options and just say webinar March. You do upload. It's uploading. This is quite a big capture, so it takes a while. Then you can click on it. Oh, there it is. But you can see here the text you enter, and if you go to more info, you get the comments to tags, comments stuff. So that's also a nice thing to have. So wireless analysis. There are some things you can do with Airtool and CloudShark. One of the first things you can do are, for example, you can find all the networks in the 2.4 or the 5 GHz band, or both. And remember that Airtool can hop through the channels, and by default, the dwell time is 250 milliseconds. If you're familiar with wireless networks, you know that they advertise their presence using beacons. These are management frames, and they do that by commonly every 102.4 milliseconds. So by having a dwell time of 250, there is a chance we can, at least get one beacon from the networks that are advertising on the channel we are set to, or we are listening to. So if we go to, let's see what networks I have in the 5 GHz band. Now we go to the analysis tools on CloudShark and we choose wireless networks. It's gonna give us a list of the SSIDs that were detected or were captured. So for example, we have this one on channel 149, 44, 52, 36, 149. So this is a quick way of doing a wireless scan for neighbor networks, see what's on nearby. Now, the other thing very interesting that you can see from a capture is that, remember that we say that when you put the NIC on monitor mode, the NIC will listen to frames that were transmitted on the channel the NIC is set to. So for example, if the wireless card is set to channel 6 and you put it in monitor mode, it's gonna capture frames transmitted on channel 6. But this is not entirely true. Why? Because in the 802.11 networks, There is something called channel overlap, and this is what it means is that the channels on the 2.4 gigahertz band, we have in the US we have 11 channels, 1 through 11. Each channel is separated by 5 megahertz, but they are 20 megahertz wide. Sorry. So that means that they overlap. So as you can see in the figure in the top, channel, for example, channel 3 overlaps with channel 2, channel 4, even channel 1 and channel 5. So what this means is that when you capture on channel 3, for example, you might get frames transmitted that were transmitted on channel 1 and channel 6. So let me show you an example now. Let's capture on channel 3. Now let's see some of the packets we got. This one, the first one, if you go to the radio tab header, this is a header that gets appended to every frame when you capture in monitor mode, and it contains information provided by the driver. It's not something that was transmitted originally, it's just appended by the driver. So here we say that so this frame was captured on channel 3, but if we go to the beacon and we look at the information elements that are transmitted with that beacon, and we look at the one called the S parameter set, this information element tells us which channel the access point is set to, and as you can see, it's set to channel 1. So this means the access point is transmitted on channel 1, but we captured it on channel 3. So what you see in this column, yeah?
That's interesting. Is it possible to build a filter that will, oh yeah, so you have it right there.
Yeah, so these two columns I added, they're not by default shown in CloudShark, so you go to Profile, and you can, they are here, you drag them, put them up here, and now you can see them here. But this, what these columns does is that they show the channel where the frame was captured on. So it's important that you know that even though it says channel 3, you still have to go to the beacon and look at what channel is actually the access point operating on. I wonder if there is another one in channel 6, but I don't. No, there's no. Well, but that's the idea. So that's something that you get because of the channel overlap. This is not the case with the 5 gigahertz channels. They do not overlap when you are using 20 megahertz channel width. Now that we are talking about channel width, so there is this other thing in wireless networks called channel bonding, which means that you can, it basically means that you can get two adjacent channels and use them together to transmit data on both channels at the same time. And this is to increase the, the bandwidth, the throughput of the network. So for the 802.11n, you can have 20 megahertz or 40 megahertz channel widths. The figure there is showing a network that is configured on channel 6. The one that's highlighted, the Voltron one, is configured on channel 6, but it's using 40 megahertz channel width. So it's using the channel that will be channel 3 as the secondary channel. The channel can be above, the secondary channel can be above the primary or below the primary. In this case, it's below the primary, is channel 3. For the, and one thing is that this type of configuration is not recommended in dense environments, especially 2.4 gigahertz, because when you do that, you are overlapping with other networks. So you are affecting or interfering with nearby networks. In the same case, if there's a nearby network of 40 megahertz, it's interfering with, it might be interfering with your network. So for 2.4 gigahertz, basically the advice is to keep it on 20 megahertz channels. For the 802.11ac, which is the newest standard, you can have 20, 40, 80, or even 160 megahertz channel widths. 802.11ac, it can only be used in 5 gigahertz. So there's more room there to use the different channel widths, although in most cases it's only advisable to use 20 or 40. Because when you use 80 or 160, the number of available channels that do not overlap, it gets drastically reduced. So you have less options to configure your network on. So if you look, so basically when you have when you do a capture and you want to look, there are many information elements in a capture in the beacon or proc response that you might want to take a look at, and one of them is the HT info or HT operation information element. The tag number is 61, or the VHT operation element, which is tag number 192. And there, as you can see in the figure, it shows information about what is the primary channel. It says channel 6 for this network, and the secondary channel offset, it says secondary channel is below the primary channel, and it's number 3. So that's how you can see from a capture if a network is using what channel width a network is using. So in this case, it's using 40 megahertz network, 40 megahertz channel width. I'm sorry. And the next one is more of a tip. When you are doing capture, it's a matter of perspective. It's all about location. So it's very important to be aware of where are you located and capturing the frames. If you capture too far away from the transmitter, you might get, or you might see a lot of corrupted frames. Why? Because if you're too far away, then the chances of being interfered by other transmitters is higher, and the signal strength is lower, and then you start to see errors in the frames. But that doesn't mean that the receiver is seeing the same errors, because if the receiver is close to the transmitter, then everything is just fine. So if you want to analyze the environment from the access point perspective, given that in a managed network, all the traffic has to go through the access point, you want to be as close as possible to the access point when you are capturing and analyzing the behavior of clients in your network. So location is very important. and one way, so it's very easy to see corrupted frames on CloudShark, the same as in Wireshark. You get they're highlighted in black, but you can also inspect the frame check sequence and in the 802.11 MAC header, and you can see there how it says that the frame check sequence is bad. So this is a corrupted frame. And the other thing that's important to monitor in wireless networks is retransmissions. Why? Because retransmissions are the symptom of many problems in Wi-Fi. You can retransmissions can occur because of interference, low signal to noise ratio, power mismatch. This means that your access point is configured to transmit at high power levels, but your client is usually configured to transmit at low power levels. So this power mismatch means that the client can hear the access point, but the access point cannot hear the client. And because of that, you start seeing retransmissions from the client side. Hidden node problem, near far problem, and other problems. So what you want to take a look is to this field. Let me show you in one of the captures I have here. Sorry, this is the wrong capture. Yeah. So to know which frame is a retransmission, you want to use a filter, and it's basically let's also say that we only want to see the frames that are not corrupted, so we can have correctly. Sorry, my mistake. All right. So all this data, all these frames are basically retransmissions. Sorry, it's here. Control. So here you have it. Here it says frame is being retransmitted. So this is a retransmission. This is also retransmission, and so on. So one of the things you can do in CloudShark is you can go to the graphs. So when you go to graphs, you can create a new graph, and basically you create the series here using filters. So this one in particular that I did for this capture, I previously identified the BSSID or the MAC address of the access point and the MAC address of a client, and I basically filter using those values, so I can get like a conversation between an access point and a client. And then I say, okay, graph me all the frames that were transmitted between the client and the access point. And this is one-way conversation, by the way. I'm only showing one-way conversation. And then graph me all the frames that are retransmissions. So in this case, you can see that at this point in time, retransmissions were very high, almost, this is the total number of frames, this is the number of frames that were retransmitted, so it's more than 50%, so something happened here that caused this high retransmission rate. And basically when what you want is to keep retransmissions below 10%, because above that you start seeing a lot of issues at the application layer, like latency, jitter, all those problems that show up in your application, that have an effect in your application behavior and in the performance of the network. So retries are a very important metric to keep an eye on when you are troubleshooting wireless networks. And that's basically it. Those were my tips for today. If you have any questions, you're welcome to do them now.
Awesome, thanks, Adrian. All right, so I said before, if you do have any questions, you can type them in the question box in the lower right-hand corner of your GoToWebinar control panel. We have one. Is there a way to graph retries by percent rather than number of packets? I don't remember if we can. I don't have access to Adrian's capture, but.
Sure. Now, right now, you can graph by packets or bytes. So the number of bytes that were seen on that period of time. To do by percent.
Yeah, I don't.
Yeah, no.
I don't think we have it. You might be able to build a filter. If you were to add another metric to the graph that shows kind of the rest of them, you might be able to see them in an overlay, but they wouldn't necessarily show them as a percentage. Our next question we have, do you have a list of your most used filters that you can share? I think that's actually a pretty good idea, and maybe that's something that we could work on afterwards and put out. I don't know if you have something like that already in your blog anywhere, Adrian.
No, I don't. And actually thought about putting a slide with common filters for, well, basically, so CloudShark supports the same syntax as the Wireshark filters. So if you go to the web and search for common wireless filters for Wireshark, you will get, there are a bunch of pages showing, what filters, basically the ones that start with WLAN, you can use in the Wireshark, and the same you can use in CloudShark. Basically the same.
Yeah. In your experience, is it better to have special hardware rather than the built-in hardware on whatever Mac you're using to do accurate testing?
To do very precise testing, yes. There is dedicated hardware that is designed specifically for frame captures. It's expensive though. But if you want to be very precise about it, yes, you might need to use that hardware. But in general, a Mac works very well for me. Yes, you might lose or you might not see some frames once in a while, but you can get a general picture of what's going on. Yeah, so I mean, the Mac works very well for me. I don't have very much experience with Linux drivers in monitor mode, though.
We have a question about will it work on OS X running in VMware Workstation if you're using like a USB Wi-Fi card.
No, it won't work. It's using the built-in Wi-Fi,
Right.
which is only accessible on a normal installation of the operating system.
Okay. Our next few questions are about some of the basic CloudShark functionality. So I'm going to grab control really quick so I can show some things. Okay, so I have a Wi-Fi capture here. So first, you're asking about those graphs, and the graphs that Adrian made can be made. I'll do one with alt traffic here. So this is a wireless capture that we did here in our lab, and we have a lot of access points going. So if you go to edit graph, you can see this here. You can save it by giving it a title. And when you save it, you can share it. You can share it with the URL. So the URL will show up here, and you can share it with someone. If this is related to another question that was asked, if it's public, you can share this URL, and anyone can view it, even if they don't have a CloudShark account. If you go to and then, so the other way to share it would be to export it. So you can export as any of these file formats right here. And the filters themselves, yes, they can be shared. So if I were to do, let's say, I'll do something simple like frame.number. Right, so now you can see up here in the URL, the filter that I typed in is part of the URL, so you can take that and share that with someone. And if you've set the capture to public, then yes, other people can view it. So Adrian, there's one more question for Airtool. Are there any plans to support USB NICs to capture multiple channels and roaming analysis?
The problem I have is that there is no support for monitor mode in external USB adapters.
So you run into the problem that you illustrated in the beginning.
Yeah, so it's I've been trying to contact, manufacturers and stuff, but because the built-in Wi-Fi works very well, there's not much intentions on the manufacturers to come up with drivers for their USB adapters for Mac. So no, right now it's not. I mean, if there is support for them, yes, I would do it, but I can't. My hands are tied there. So.
All right. There was one other question. So I don't have a good example here from a Wi-Fi capture, but if you actually have encrypted data that was passing over a Wi-Fi link that you have, someone is asking if you can decrypt that, and you can. So if you know the wireless key, you can add a decryption rule. So here you pick the SSID and the type, and then you put the value in here, and that will decrypt the capture. All right. Well, thanks so much, Adrian. This was really, really insightful, I think, for a lot of people. If you need any of those resources, if you need anything from us, you can reach us at support@cloudshark.org or view our YouTube channel. And I'll be putting a recording of this up there pretty soon. And that is Adrian's website there, where you can download Airtool and some of the other things that he's developed as well. There's some much more advanced tools than just Airtool there. And you can find us always both on Twitter.
All right.
All
Thank you,
right.
Jason.
Thanks so much, and everyone enjoy your day.